In this video, we will solve quadratic equations using the square roots property. The first objective we're going to talk about is the square root property. If x and k are complex numbers and x squared equals k, then we can solve for x by taking the square root of both sides, thus giving us x equal to the positive square root of k or the negative square root of k. Since my quadratic equation is x squared, I should have two solutions. When you have x squared equal to a number, you're going to have both the positive and the negative square root solution. If you think about it, if I were to resubstitute the square root of k into x squared, when you square it, it will become positive. The same thing would happen if you were to substitute negative square root of k and square it, you would get a positive k. Thus, we would get two different solutions. Remember that if k is not equal to 0, using the square root property always produces two square roots, one positive and one negative. So let's practice the square root property on some of these quadratic equations. X squared equal to 81. So since there's no linear term, I can use the square roots property and take the square root of both sides. So that would give me x equal to plus or minus the square root of 81, which we know we can take out. The square root of 81 is actually 9. So x is equal to both positive and negative 9. X squared equals 22. Same process. Take the square root of both sides. So x is equal to plus or minus the square root of 22. Now in this problem, 22 cannot be broken down with any perfect square factors. 4 will not divide into it, 9 will not divide into it, 16 will not divide into it, and then anything else would be too high. So this is as far as it'll go. The positive square root of 22 and the negative square root of 22. In an example like this, 4t squared equals 108. What you need to do before you try to solve is get the variable, the squared variable by itself on the left side. So first thing I'm going to do is divide both sides by the 4, just like in any other equation. So we get t squared equal to 108 divided by 4, which is 27. Then apply the square roots property. So t equals plus or minus. Don't forget the plus or minus. The square root of 27 can be broken down to as 9 times 3. So simplifying that radical expression, the square root of the 9 can come out from under the radical, so 3, and then you have a radical 3 left underneath. So the positive 3 square roots of 3 and negative 3 square roots of 3. Two solutions for each equation. All right, a couple more. The quadratic equation x squared equals negative 49. In this case, we don't have a linear term, so I can use the square roots property. So if I take the square root of both sides, x will equal the square root of negative 49. Now, if you remember from previous lessons, if you have a negative underneath the radical, we have to factor out the imaginary unit I. So we have 49. I forgot my plus or minus. Got to make sure you put that in there. So x equals plus or minus. The square root of 49 actually comes out. So that's square root of 49 is 7. So 7i plus or minus 7i. Got to have both the positive and the negative solution. All right. Same process here. 12x squared equals 49. I'm going to do the same thing I did in that previous example. We are going to factor out, we're going to get divide off the 12 off of both sides. First thing, to get the perfect square alone. So I have x squared equal to 49 twelfths does not reduce in any way, so we're just going to leave it the way it is as a fraction. Take the square root of both sides. So x would equal plus or minus The square root of the numerator, square root of 49, would come out as just 7. The square root of 12, though, we can simplify 4 times 3, so that would be 2 square roots of 3. And as you can tell, my solution is not in rational form. It needs to be rationalized. No radicals in the denominator. So if you remember from your previous algebra courses, to rationalize the denominator, we're going to multiply by radical 3 over radical 3. So that's plus or minus 7 square roots of 3 over. Now on the bottom, when you simplify this, radical 3 times radical 3 just comes out as 3. So this is 3 times the 2 that we've already got, which is 6. Notice I can't reduce anything, so my answer is plus or minus 7 square roots of 3 divided by 6, both the positive and the negative. All right, I'm cutting this off a little bit. Let's move that up. Solve using square roots, the same thing. So this looks a little different in the fact that you have a binomial squared equal to a number, but this is still considered a perfect square. So we're going to use the same zero product property here, the square roots property, to do this. So the square roots property, we're going to take the square root of both sides to undo the square. So when I do the left side, I get x minus 2. The square root of x minus 2 squared would just come out as x minus 2. Now we have to have two solutions. So on the right side, plus or minus, don't forget that. And the square root of 49 actually comes out evenly as 7. Now this is one little extra step that you have to add to the process. If you're going to solve for x, then you need to get it by itself. So I need to add 2 to both sides to get rid of that minus 2. So I'm going to actually add 2, but I'm going to put it in front of the plus or minus sign to kind of help me extract my two solutions. So in this case, we have x equal to positive 2 plus or minus 7. Now that actually will extract two real solutions here. 2 plus 7, which would be 9. That's one answer. And 2 minus 7, which is negative 5, would be my other solution. So you can actually extract the rational answer out of the problem. So you need to go ahead and complete this. If you can add and subtract the numbers, you should do so. So let's do another one just like that. If I take the t minus 1 quantity squared equals 18. So if I take the square root of both sides, on the left side I will get t minus 1. On the right side, we have plus or minus. We need to see if we can break down the square root of 18. And 9 will go into 18 2 times. So if I use 9 times 2, we can bring the 3 out and leave the 2 underneath the radical. So in the next step, all I have to do is get t alone. So I'm going to add 1 to both sides. I'm going to put it in front of the plus or minus sign. So t will equal positive 1 plus or minus 3 square roots of 2. Now, as you remember from previous algebra courses, these two terms cannot be combined. For you to be able to combine this term and this term, they would both have to have the square root of 2 attached to them. So in this problem, you have the solution 1 plus 3 square roots of 2. The other solution would be 1 minus 3 square roots of 2. So this is as far as you can take this problem. Let's do one last problem to kind of reinforce what we've learned about the square roots property. 3 times 4x minus 1 squared plus 1 equals negative 17. So the first thing I need to do is get the perfect square isolated on the left side. So the first thing I'm going to do here is subtract the 1 from both sides. So I have 3 times 4x minus 1 squared equal to negative 17 minus 1 is negative 18. Now I'm going to get the square alone by dividing both sides by this 3 that's been multiplied. So we're going to divide the 3 off both sides. So I have 4x minus 1 squared equal to Negative 18 divided by 3 is negative 6. Now I can apply the square roots property. So we're going to take the square root of both sides, which gives me 4x minus 1 by itself on the left, equal to plus or minus the square root of negative 6. Now we know that the negative underneath will come out as an I, and we cannot simplify the square root of 6. Alright, so we've got some more steps to kind of get x by itself. So I'm going to come up here and work this out. So I have 4x minus 1 equal to plus or minus I square root of 6. So to solve for x now, I need to get it by itself on the left side. So I'm going to add the 1 over to both sides. Remember, I'm going to put it in front of the plus or minus sign. So I have 4x now equal to positive 1 plus or minus I square root of 6. And the last step I want to do to get x alone, I'm going to divide by 4. So we're going to divide the whole thing by 4. So x is actually equal to 1 plus or minus I squared root of 6 over 4. Now, if you're using the software to do the online course, you need to separate your answers out. I didn't do this on previous examples, but let's look at this one. If I were going to separate my two answers out, one answer would be 1/4 plus the square root of 6 over 4 I. There's one of them. And the other answer would be 1/4 minus the square root of 6 over 4 I. Notice we got the both as complex solutions there, so we have to separate those out as two different answers.